Hello people, this is Srinidhi here. Again, I welcome you back for this video. See, in this video, it's quite interesting and the topics look very simple, but still people find it difficult, sir. What is risk? What is CISC? We have studied actually in the computer organization, but still, okay, you need to have some points or the other so that having those points as a basic, okay, you'll be creating a basic thought like this is what a risk architecture is, this is what CISC is, and basic difference between risk and CISC. So this video is dedicated for those people for having a clear distinction between risk as well as CISC. Okay, so with me here I am having, see, I have listed out a few points with respect to risk and CISC. Okay, so today we'll go accordingly to the points. See, if I start explaining points, there can be huge number of points which I can give definitely. But when you ask me in one shot, sir, what is the difference between risk and CISC? To be in very one precise definition, giving an answer in one shot, I can tell you in a CISC processor, the instructions or anything is of variable size. Here in ARM, that is our RISC processor, is based on instructions are fixed length. Okay, so CISC processors has a variable length instructions, and RISC we have a fixed length instruction that is of 32-bit. Here in CISC we have, it can be 8-bit, it can be 16-bit, or it can be more than that. Okay, so here that is the very first point which I have mentioned here. So instructions are of variable size. So here in this case, instructions are of fixed size, whereas in case of ARM we have 32-bit instruction. So the instruction is fixed. So we have studied actually in one cycle 32-bit instruction is fetched simultaneously. I hope so you are able to understand this concept because it's very important. Students fail to understand this concept. Why? Because they show, see, there'll be some little kind of negligence, right? So at the end we can concentrate on these points. See, you can't by heart this point, my dear friends. You can't really by heart this point. You have to understand the architecture. So if you understand the underlying architecture between each of the concept, I think it will be really a cakewalk for you guys in the writing in the examination, irrespective of how many points if you want to write. Okay, so we'll go with the next point. Here it is multiple fetch operations. See, it's important. Okay, just bear with me. I'll be not discussing too much in detail. Okay, so since it's a small topic, okay, but it's too important topic. So in the examination and VTU, he'll be asking you this question more, or what is the difference between RISC and CISC architecture. Okay, it will be definitely a 7 marks question or an 8 marks question depending on what weightage he asks. Okay, so let's come to the point. See, in CISC processor, I told you instructions are of variable sizes. So if the instruction is of variable size, one instruction is of 8-bit, another instruction is of 16-bit, the fetching, decoding and execution, that is the overall instruction cycle to execute a single instruction, may vary. I repeat it again. Since we have the instruction of variable sizes, we cannot fetch the instruction or decode the instruction or execute the instruction in one single cycle. Please understand this. Okay, so multiple fetch operations happens, multiple I'm not sure whether how many decoding cycle may takes place, and also how many cycles your execution may takes place. Okay, so this is with respect to your CISC processors. But with respect to my RISC, you know that ARM is very beautiful. In one single shot, all the 32-bit instructions are fetched. I hope so. For God's sake, we have 32-bit database also. So one shot, all the 32-bit data we can just manipulate with all the registers here. And it requires a single cycle of execution. So it is very much important. In CISC, we have multiple cycle of execution. In RISC, we have single cycle of execution. So that I see it's a just a the concept of pipelining, which I can say. So in pipelining, we have should I explain pipelining once again, again and again? It takes me much time. Okay, I hope so you understand. One cycle, all the 32-bit, one single instruction in one cycle. Done. Did you understand? Did you understand? Yes. We'll move further now. So third point we have, we have operates on both registers and memory. See, CISC processors, as I said, whether it's 8051 or 8086 processor, those are all the age-old processors which work both on memory as well as the registers. But in the previous video, if you could remember, I have told you, I have insisted you more than 2 or 3 times that a RISC machine, that is my ARM7 processors, are always based on registers only. There is no concept of memory. That's of course, no concept of memory means what? Only it obeys load and store. 2 instructions are dedicated. One is for loading of instruction, second is of storing for instructions. So apart from load and store instructions, rest all other instructions are dedicated to registers only. I hope so you understand. Please, it's not that damn boring, right? It's quite interesting. Okay, please listen. Next, we have many addressing modes. Here we have less addressing modes. What does it mean? Many addressing modes clearly specifies that. See, I told you many instructions. See, if instructions are multiple, like for example, I can give you an instructions. See, memory, I told you that CISC processor operates on both memory as well as registers. If I take an add operation, so add operation is same, but my instruction has to be written one for memory. For operating with memory, I have to see, if suppose add r0 comma square bracket of r1, if I tell, that is for your with respect to memory. With respect to register, add r0 comma r1, if I tell that, this is with respect to register. So my operation is same, addition is same, but I am writing it for 2 things. One is for memory, one is for register. So this is in case of CISC. That is, my instructions are more. Okay, that's why my instructions are more. Instruction means we have more addressing modes. Okay, so we have here less addressing mode. Why? Because we just concentrate mainly upon registers only. We have 7 addressing modes, so it's a separate topic. I'll be making video of that also. So for this instance, so this contains more addressing modes, this contains less addressing modes. Okay, so next thing we have instruction is large. So here we have instruction is less. So I hope so. See, instruction is large means what? That is what it's almost similar to the previous thing what I told you. See, based on number of memory, see, for memory we'll be writing few instructions. Few instructions are written only to manipulate with the registers. But here in case of ARM, that is a RISC architecture, we have only with the registers, so less number of operations, so less number of instructions are required. Okay, so here if I have written reduced instruction, see, reduced means if you think like what I can say, if you think like, see, addition is there, subtraction is not there, multiplication is there, division is not there, so it's not like that. Definitely if you think like that, reduced means there is less number of instructions, or there have been number of instructions which have been deleted when it compared to CISC architecture. No, my friends, definitely it's not like that. Okay, reduced means less number of instructions with rigidity. In case of CISC, addition operation, addition instruction is there for 2 things. One is for memory as well as register. Here add means it is confined, that it is only working with registers only. I hope so you understand this topic. Please don't have any doubts with respect to this. Okay, instruction set is complex, instruction set is simple. Okay, that's why we tell that, see, complex, simple, these things are like deciding whether how the instructions looks like or the operations. Okay, since more and more number of operations with respect to memory as well as program is depend, the length of the instruction increases. Okay, so that's why in CISC processors we tell that an instruction is complex. Since here we are manipulating only with registers, the instructions will be very much small. The operations holds the rigidity and it is very much rigid in nature, so that this operations will be done in exact number of cycles which this processor requires. Okay, so that is one thing. Next we have decoding is complex, decoding is easy. So decoding, when I come to decoding, see, if I take the concept of CISC processor, see, I'll give you a small example. An instruction is being fetched from the memory, it has been executed in the processor, or let's say in CISC, sorry, I'm talking about CISC, right? So in the memory itself, it is running your instruction. Next I want to, it is being decoded, the first instruction is being decoded or executed. Let us say during execution, I want to fetch another instruction. So where is the instruction now? It is in the memory. Where is the execution cycle is happening? That is also in the memory. Okay, if I want to take up the second instruction which is residing in the same memory, I want to halt the first instruction which is being executed or decoded in the same memory, stop that, fetch the second instructions, right? So that's where your execution or decoding, say again here n number of instructions, since it is being complex. See, instructions will be again basically it is in the form of zeros and ones. So when the number of instruction size increases, the opcode also increases. I hope so you are understanding this. Please don't make the things complex. Okay, it's very simple. You have an instruction, the instruction is growing more such that it has been complex. If you have a complex instruction, it is generating an opcode which is also complex. So what did I tell? How did we define decoding? Decoding means understanding the opcode, the technical definition which I told you. See, if the length of the opcode increases, understanding of the opcode is also difficult. So it means that decoding is complex, whereas here it's quite easy. In one shot, my decoding is, because it mainly depends on the pipeline concept. Okay. So multiple execution cycle, I don't know how much times of cycle it requires for one single instruction get executed, because it varies with the instruction size also. So depending on the size of the instruction, your execution cycle may vary. So for fetching an instruction, it may take 1 or 2 cycles. For decoding, it may decode within a single cycle, or it may take about 2 or 3 more cycles. That is with respect to your CISC processor. But when it comes to your RISC processor, the execution cycle is 1, decoding cycle is 1, fetching cycle is 1. In one single shot, everything is done. Okay, that is with respect to your RISC processor. So pipelining, we studied what is pipelining is. So since there are variable size execution, there is no concept of pipelining. So I just want to draw, I just want to tell you this. See, understand here. See, with respect to, this is with respect to CISC processor. Okay, in CISC, fetch, decode, execute, fetch, decode, execute, fetch, decode, execute. This is with respect to your CISC processor. So instruction 1, that is I1 enters the system, it fetches, decodes itself, executes. This is I2, this is I3, or next continuous execution takes place. This is with respect to your CISC. See, observe RISC. How beautiful it is if you can observe here. See, I'll just draw here. My first instruction started fetching, that is in one cycle. Second cycle, as soon as it starts decoding, your second instruction is fetched. Third cycle, your first instruction completed decoding and started executing. Your second instruction is decoded and your third instruction is being fetched. So here it is fetching of first instruction, decoding of first instruction, execution of first instruction. So when it is decoding, your second instruction, that is fetching of second instruction takes place. When you are fetching next stage, when it is being decoded, that is second instruction is being decoded, your third instruction is being fetched. So I hope so you understand the concept of pipelining. What do you mean by pipelining? Dividing an instructions into a number of tasks and overlapping them. So first instruction get fetched, then it gets decoded. As soon as it getting decoded, your second instruction is being fetched. As soon as the first instruction is being executed, second instruction gets to decoded and the third instruction get fetched. As soon as the first instruction completes its execution, second instruction does not wait, it need not wait. Okay, we have discussed the pipelining. I don't want to discuss it again and again. So this is how pipelining. So it is poor pipelining with respect to CISC. So here it is excellent pipelining, that is 3-stage pipeline, works very superb way. Okay, see, your CISC processor are always flexible. Your RISC processor are always rigid in nature. See, understand, flexibility means what? See, instruction can be of variable size. It has very free, it has left to the user depending on whatever the instruction size may be. So, but in case of RISC, it is not like that. You have to give your instruction, one instruction size must be of 32-bit only, so that it is very rigid nature. But it also affects the performance also, which is more performance. Okay, RISC will be having more performance when it compares to CISC architecture. The main and last distinction where your CISC and RISC are deployed. See, CISC processors are mainly used in computer system, that is microprocessors. Okay, microprocessors or MIPI, we call it as MIPI, uses the concept of CISC. This is with respect to small systems. Okay, this cannot be extended. Okay, it's limited period. See, MIPI has several disadvantages. Okay, it has its own advantages too, since it has, but MIPI is very poor with respect to the registers and all. But when you compare your MIPI, we have come along with the far way from the age-old microprocessor. So MIPI come into existence, that is MIPI is based on RISC processor. So this is what I had. It's a small topic which I wanted to share with you people. I hope so you got a clear understanding of RISC and CISC architecture, which actually acts as the basis of thought school for a whole understanding of this whole subject. Okay, so keeping this as a basis, for the next video I'll be doing with the addressing modes. Okay, programmers model, lots and lots of topics have been left out, which I'll be updating on a daily basis. But please don't mind, just subscribe to this channel so that you will be updated with. If you have any doubt, please just don't feel difficult to drop down any doubts. Doubts are always welcome. In fact, I can improvise myself by solving your doubts. If you have any doubts or suggestions, and if you are not understanding the points quickly which I am telling here, just drop down those in the form of comments so that I'll read the comments and try to improvise myself. Okay, so these were all the things that I wanted to tell you. Just go with the video. If you are not able to understand, I'll get back to you again. Okay, thank you, all the best. We'll meet in the next video.